Hi guys, welcome to the video, and today we are looking at the conservation of linear momentum. So what is the conservation of linear momentum? Well, this is just some theory that it's a theory that says uh, the total momentum of these balls before they bump into each other is going to be the same as the total momentum of these balls after they bump into each other. Let us get into it. It goes like this. This is the definition. The total linear momentum of an isolated system remains constant, right? Well, I know I haven't explained it yet, but it's gonna make sense soon. Okay, so there's a part in the definition that says the total linear momentum of an isolated system. Isolated system. So the isolated system means that we don't have external forces acting on these balls. We don't have forces like friction, because if we had friction then the results would change, right? So it means that these balls are just balls and they are moving under their own terms, right? There are no external forces that are acting on these two balls, right? So back to the conservation of linear momentum. It means that the momentum, the sum of the momentum of these balls, or the total momentum of these balls, are gonna be the same before and after the collision, right? Meaning that if you were to calculate that both the momentums of momentums wow both the momentums of these two balls were like 3, it means that even after they have collided, it's still going to be 3, right? Provided the system is isolated, there are no external forces. I'm gonna do a recap, and in the next video we are going to do some calculations for the conservation of linear momentum. The conservation of linear momentum goes like this in definition. It says the total linear momentum of an isolated system remains constant, right? It is conserved. It means that the total momentum of these balls, these two balls, before collision, because mainly we are dealing with collisions here, it means that the total momentum of these balls before the collision is going to be the same as after the collision. So if you calculate the sum of the momentums of the balls to be, let us say, 500 before the collision, it means that it has to be 500 after the collision, right? That is what the conservation of linear momentum mean, right? So if maybe you were to calculate that the sum of the momentums of the balls is 20, and on the other side after the collision you find that it is 30, yeah, this is no longer the total linear momentum is no longer conserved, right? Something has happened, there was an external force or something, right? So yeah, I'm gonna see you next time. Do not forget to like and subscribe, and I guess we're gonna dive deeply into the calculations next time, because this is just me giving you the concept that the total momentum of the two is the same before and after. Well, let me put before